Welcome to Ultraconcurrent Laboratory on Low-Pass Filter. It has 4 different views. The schematic view shows the first-order low-pass filter using RC network. It has variations in 2 circuit parameters and 1 signal parameter. In low-pass filter schematic, it is possible to select one of the 3 possible values of resistor R. Similarly, it's possible to select one of the 3 capacitor values. The laboratory also has the feature of varying the input signal frequency also. The input frequency can be one of the 4 values. This will result in as many as 45 different first-order low-pass filter time responses. The circuit view shows the real-time implementation of first-order low-pass filter on the breadboard. The LEDs indicate which combination is being in action at the given time. Oscilloscope view shows the time response of the low-pass filter. Oscilloscope has 2 waveforms where yellow corresponds to input and the blue corresponds to output waveform. The Bode diagram shows the frequency response of the low-pass filter. Let's observe the effect of input frequency on the low-pass filter. Let's start the analysis with resistance of 1 kΩ and capacitance of 0.1 microfarad. This results in a cutoff frequency of 1.59 kHz. With the input sine wave frequency as 100 Hz, observe the peak-to-peak amplitude of input and output are 2.04 volt and 2.06 volt respectively. As the frequency increases to 500 Hz, the output amplitude becomes 1.98 volt. And for 1 kHz frequency it is 1.80 volts. And when the frequency 2000 Hz is just after passband, the amplitude is 1.40 volts. And as frequency increases to 4000 Hz and the output amplitude is 900 millivolts. This way you can observe that as the input frequency is lesser than cut-off frequency, the output amplitude is more. It decreases as the input frequency is closer to cut-off frequency of the filter. It's also possible to observe the phase difference between the 2 waveforms as the input signal varies. You can repeat the above steps for other combinations of resistor and capacitor. Let's observe the variations of different circuit components on frequency response of the filter circuit. Let's start the analysis with resistance of 1 kΩ and capacitance of 0.1 microfarad. For analysis purpose, 4 cursors are placed at appropriate locations. Cursor 1 is placed in the passband frequency, and cursor 2 delta 1 cursor is placed at strategic location where the magnitude is 3 dB down from the passband gain. This frequency corresponds to cut-off frequency of the filter. Cursor 3 and its delta cursor are placed in the transition band. The difference in magnitude with frequency ratio shows the roll-off of the filter. With resistance of 1 kΩ and capacitance of 0.1 microfarad. Observe cursor 1 at 222.53 Hz. With channel 2 magnitude -0.1096 decibels. And phase of -7.28221 degree, whereas ideal values are 0 dB and 0 degree. This corresponds to magnitude at passband and phase in passband. Cursor 2 delta 1 is placed at -3.05 decibels and the corresponding frequency is 1.7986 kHz. And the phase in -44.79 degree. Usually ideal values will be 1.59 kHz and -45 degree. This corresponds to cut-off frequency and phase at cut-off frequency. The ratio of magnitude to frequency of cursor 3 and its delta is found to be -18.9115 dB per decade, whereas ideal value is -20 dB per decade. This corresponds to roll of the filter circuit. Now with capacitor at 0.1 microfarad and resistor at 10 kΩ. Let's observe the important parameters on the Bode plot. At cursor 1 the obtained frequency is 34.939 Hz. Magnitude is -0.32 decibels. And phase is -11.549 degree, whereas the ideal values are 0 dB and 0 degree. At cursor 2 delta 1 the obtained frequency is 180.14 Hz. Magnitude is -3.35 decibels. And phase is -45 degree, whereas the ideal values will be 159 Hz and -45 degree. Cursor 3 and its delta is found to be -18.69 dB per decade. But ideal value is -20 dB per decade. This way you can repeat for other combinations of resistor and capacitor. Please subscribe to Labsland and perform all different combinations and understand the low-pass filter concepts thoroughly.